You know, there's a really weird dent in Earth's magnetic shield, and for years we've had some standard ideas about what causes it. But what if we've been looking in all the wrong places? What if the key to this mystery lies on the complete opposite side of the planet? Okay, let's dive into this very different look at the South Atlantic anomaly.
So, take a look at this map. This is the South Atlantic Anomaly, or SAA for short. That big red area hovering over South America and the Atlantic? That's where our planet's magnetic field is at its absolute weakest. And this isn't just some scientific curiosity, it's a big deal. This weakness lets dangerous high-energy particles dip way closer to the surface, and that's a real problem for any satellites or spacecraft passing through.
Now, the usual scientific explanations, they tend to point deep inside the Earth's core. But one researcher has come up with a pretty wild alternative. What if the source of this problem in the Atlantic isn't in the Atlantic at all? What if it's more like an echo, a reflection of something happening a full 180 degrees around the globe?
So here's how we're going to break it down. First, we'll get a handle on what the SAA actually is. Then we'll look at a really surprising discovery on the other side of the planet. From there, we'll explore this new theory of reflection, see how it claims to solve all the SAA's weird features, and finally, figure out why this thing is constantly on the move.
Okay, so let's start with the basics. What exactly is this anomaly that's causing so much grief for our technology up in orbit?
Well, officially, the SAA is the spot where that dangerous inner radiation belt gets closest to us. And that happens because of a huge dip in the planet's magnetic field. Seriously, if you think of our magnetic field as a protective shield, this is the place where it's basically paper thin.
Now, the standard explanations get pretty complicated. They talk about things like the Earth's magnetic and spin poles not quite lining up, or about strange things happening deep down in the liquid outer core. But the theory we're exploring today says, hold on, maybe this is all way too complex. It suggests the answer is actually far simpler, based on a mechanism the standard model might have just overlooked.
And this is where things get really interesting. The clue, according to this research, wasn't found by looking deeper into the Earth's core, but by just looking at a map of the entire planet.
This quote from the author, this is the light bulb moment. He realized that the SAA is located almost perfectly opposite a totally different kind of anomaly, a gravitational one, which was mapped out by the European GOCE satellite.
Just look at this comparison. On the left, you've got the SAA, that magnetic low point, and on the right, using data from that GOC satellite, you see a gravitational high, that big yellow area centered right over Indonesia. They are on exact opposite sides of the Earth. The author of this theory believes that's no coincidence at all. He thinks they're two sides of the very same coin.
Okay, so if they're connected, how on earth does that work? This brings us to the absolute heart of this new theory, a mechanism of reflection that travels straight through the planet. All right, to really get this reflection idea, we first need to wrap our heads around the author's foundational concept, something he calls a unified field. He proposes that what we call gravity isn't just one force pulling us in. Instead, he sees it as a balance between that inward pull and an outward flowing energy field he calls a charge field. For this all to work, you just have to imagine this constant flow of energy radiating out from the Earth.
And this diagram here shows how it supposedly works. According to the theory, this outward charge flows from the North Pole right through the Earth. When it hits the incredibly dense tectonic plates under Indonesia, something amazing happens. It doesn't get blocked, it gets reflected. This reflected energy then continues its journey straight through the Earth and pops out on the other side, right where we find the South Atlantic anomaly.
Now, this theory predicts that this huge flood of reflected charge pointing out of the Earth should create a gravitational low in that area. And would you look at that, the GOCE satellite data confirms it. That blue patch, which represents a low point in gravity, is sitting right over South America, a perfect match for the SAA's location. So you've got a proposed cause and a confirmed effect.
But a good theory has to do more than just explain why something is where it is. It needs to account for all the other strange little details about the anomaly. So let's see how this reflection model holds up.
And this is the big one, right? If this whole area is getting blasted with extra charge, with all this energy flowing outward, shouldn't that create a magnetic high? Why is the SAA famous for being a magnetic low?
The theory's explanation for this is, well, it's pretty wild. It suggests the reflection process literally inverts the properties of the energy particles. These new upside-down particles then generate their own opposing upside-down magnetic field. So as this opposing field rises up from the ground and meets the Earth's normal magnetic field coming down, they basically just cancel each other out. And the result of that cancellation? A net drop in magnetic strength, which is exactly the magnetic low we see.
Another weird thing is that the SAA has a tail that stretches to the east. Normally, you'd expect any kind of drag from the Earth's spin to create a tail pointing west, backward. But the author proposes a charge wind. Because this charge is coming out of a spinning Earth, it gets flung forward, creating a forward tail that points east, perfectly matching what we observe.
All right, let's hit the last piece of this puzzle. The fact that the SAA isn't just sitting still, it's drifting year after year. This theory says forget about the tectonic plates moving, they are way too slow. Instead, it's all about simple geometry. This diagram shows the key players. You have the North Magnetic Pole, the fixed reflection point under Indonesia, and the resulting SAA. If you change the position of the pole, the whole angle of reflection changes, and that means the location of the SAA has to change too. So it's a pretty simple chain reaction. We know for a fact the North Magnetic Pole is moving. As it moves, the angle of the charge hitting Indonesia changes. That, in turn, changes the angle of reflection, which causes the SAA's location on the other side of the planet to shift. And the author claims the speed of the pole's movement lines up with the observed drift of the SAA. So there you have it, a theory that tries to tie everything together with one single elegant idea. The SAA's existence, its exact location, its weird magnetic properties, that strange eastward tail, and its slow drift. All of it explained as a consequence of this proposed charge reflection from deep under Indonesia.
It's a fascinating model, right? All built from a single, unexpected connection between two opposite points on the globe. And whether it's right or not, it really challenges us to think differently. It leaves us with a pretty big question. Could a dent in our magnetic shield over the Atlantic really be an echo of dense rock on the other side of the world? And if so, what other global mysteries might be connected in ways we haven't even started to imagine?